Okay, here is a another use for the sum and difference formulas here, and basically this is more an exercise in putting pieces together and using the formulas in a rewarding way, and kind of integrated with what we already know. Okay, so basically what it's asking us to do is to evaluate this. Okay, given that the sine of alpha is in the first quadrant. Okay, so what we're going to do is that we're going to set up a scenario here, and we're just going to use, it doesn't have to be perfect, we're just going to set up like a little dummy triangle here, no offense to the triangle, and we're going to set up alpha here. And so basically what we're looking at is this, is that we're creating, again, this triangle that is going to have these properties. Notice it again, first quadrant, it's a right triangle here, and we know that the sine of alpha is 4 over 5, which means the opposite over the hypotenuse here. Okay, now when we have these triangles like this, we also want to probably fill in the last side. Okay, and the last side using the Pythagorean theorem is going to give us 3, which showed the work off to the right there, just using the Pythagorean theorem real quick. Okay, so that's our first triangle. Now, what we want to know also is the cosine, because when we have the sine of alpha plus beta, we're going to have a cosine values and sine values, and you notice that up here we have cosine and sine values of both alpha and beta sprinkled on the right hand side, completing the formula. So let's set up this triangle here, and notice that it is in the second quadrant, and again the triangle doesn't have to be proportional, it just has to a placeholder for everything, and this is going to be beta here, the reference angle. And we notice that it is going to be a negative 12 over 13, but let's just fill in the sides right now and not worry about that. Okay, so this is going to be the adjacent, so that's going to be 12, and this is going to be 13, and so using the Pythagorean theorem to find the last side, it looks like it is going to give us 5. Okay, so I'm going to go ahead and put 5 here, and it appears like we are ready to go. And remember that this is in the second quadrant. So once we get this set up, okay, and we can start to take these triangles and read the values from them to go ahead and complete the problem. So let's take a look at completing the problem. I'm going to write it in the center here. So we want to find out what this is given these two facts. And so I'm going to write, we need the sine of alpha, okay, and I'm just copying right up top here, sine of alpha times cosine beta, okay, it's adding right here, so I know I'm going to be, that's the same relation right there, so that's going to be a positive, and then we got sine of beta cosine alpha. Okay, so from here we can read it right off the triangle. So what I'm going to do is this, is that I'm going to, all right, take a look, sine alpha, that is given to us, so I know that that is going to be 4/5. Okay, it's given to us up above. Cosine beta is already given to us as well, and that's going to be a negative 12 over 13. Plus, and now I got sine of beta. Now I have the completed triangle, and now I can go ahead and read the opposite over the hypotenuse, and it's in the second quadrant where sine is positive as well, and so therefore that's going to give us a positive 5 over 13, and we got the cosine of alpha. The cosine of alpha, we have the side that we got from the Pythagorean theorem, we got 3 over 5, adjacent over hypotenuse, and so therefore we have 3/5. Okay, like that. And so now we just need to go ahead and do the arithmetic with this. And so let's do that. Okay, so multiplying these fractions out, I get this guy, and I just used a calculator here and then converted it fraction button. And so when I add those up, I believe I'm going to get, for the final solution here, a negative 33 over 65. Okay, so that is the final solution right there. And that's how you do that kind of problem. And yeah, see you in the next video.